Today we're looking at composite functions as part of the higher maths revision for either your prelim or for the final exam. We're going to look at 4 questions today, part of an assignment that I've given out. Question 4 is a real challenge, I think it's a beauty. Let's start with question 1. As usual, what you can do is you can freeze the video, try the questions and then follow the solution. Right, let's go through it reasonably quickly because you can freeze it at any time. Right, so functions, I've got 2 functions here, f of x and g of x. Okay, x squared plus x for f of x and 3x minus 1 for g of x. Right, so what I have to do is I have to evaluate g of f of 2. Okay, what I'm going to do is I'm work out a g of f of x function first, where I can substitute any number in. So that's the thing I'm going to go for first of all. Okay, so I'm going to go for part A, part 1. What I'll do is I'll go for a g of f of x function first of all, okay? First thing I'm going to do with composite functions, I've got g of f of x, I'm going to put the f of x function into there. So what I've got is I've got g and then that function there, which is just that one that I've put inside that bracket there. That's all I've done. Next thing I'm going to do is I'm going to look at the g of x function. And wherever I have x in the g of x function, it's there. Wherever I have x squared plus x, I'm going to put that in where that x is. So I'm going to replace x with x squared plus x. So there's the 3 from there. I'll open the bracket up. There's a minus 1. Okay. And inside there where x is, I'm going to put x squared plus x. I'm then just going to multiply that bracket out, so 3x squared plus 3x minus 1. Okay, and that's me got a formula for it. Right, so from there, what I'll do is I'll do the question that I've asked to be done. So g of f of 2. So all I'm going to do is I'm going to substitute a 2 in where my x is. So 3 times 2 squared plus 3 times 2 minus 1. So that'll give me 4, 12, 18 minus 1 will give me 17. So there's my first answer there. For part 2, let's have a look at that. So part 2's asked me to go for f of g of minus 1. I'm going to go for a function first and work that out. So same as I've done up here, I'm going to put in the g of x function. So the g of x function is 3x minus 1. So I'll put that inside the bracket. What I'll then do, wherever I see x in the f of x function, so it's there and there, that's where I'm going to substitute the 3x minus 1. Right, so first thing is 3x minus 1, and in the f of x function that's squared, I'm going to add on to that 3x minus 1 again. So that's me substituted the functions in together. So let's just work this one out. So you can multiply this bracket out by FOIL if that's the way that you've been taught, or if you know the quicker way, we'll just go ahead and do that. Square the first term, so that's 9x squared. Multiply these together, so that's minus 3x, double it, minus 6x. And we'll square the last term, so that'll be plus 1. So that's minus 1 times minus 1. And then what I've got here is plus 3x and minus 1. I'm going to gather all these terms up, so I've got 9x squared, I've got minus 3x, and the 1 and the minus 1 will cancel out. So there's my formula for that one first of all. Right, what I've been asked to do is to find out f of g of minus 1. A lot of ofs in here. So I'll substitute a minus 1 in here. And what I'll do is I'll work that through. So minus 1 squared is going to be 1. 1 times 9 is going to be a positive 9. And minus 3 times minus 1, that's going to give me a positive 3. So my final answer here is going to be 12. Okay, so that's the first two parts done. Down below, I've got for part B, I'm going to start off with, I'm going to find the formula for f of g of x. So I've already got that. Here it is here. So from above, I'm just going to write that formula down. So it's just f of g of x equals 9x squared minus 3x. And that's that complete. Right, so part 2, that was part 1. Part 2. Okay, same kind of thing. The only difference is I've got a different letter there. So same thing from above. a g of f of a will be this function here. So g of f of a is going to be 3a squared plus 3a minus 1. And that's the answer to that part there. Okay, so for part 3, so it'll be b part 3, I'm just going to go up to here. So this is b part 3. Okay, I have to find f of k. So I've not worked that one out yet here, so I'll work out an f of x formula first. Okay, so what I've got is the formula I'm going to use is this one here. So the first substitution for the first mark, I'm going to put that formula there into there. I'm then going to put, so I'm working on itself, I'm going to put x squared plus x into here and also into there. So that's what I'm going to do with this. Okay, so what I've got is I've got x squared plus x, and that there is squared, just coming from this part here, plus, and instead of x I'm replacing it with this here again, x squared plus x. So there's what I've got to work out. So again, instead of working with FOIL, I'm just going to work this one out here. So square the first term, so that will be x to the power of 4. I'm going to multiply these together, so that gives me x to the, that will give me, what have I got there? So I'll get x squared, so it's going to be squared, x times x squared, gives me x to the power of 3, and I'm going to double it, so that's going to be plus 2x to the power of 3, and the last term here, x, I'm going to square that, so it's just going to give me plus x squared. Now out here I've still got plus x squared, and I've got a plus x, and I'm going to gather all this up at the end. So x to the power of 4 plus 2x to the power of 3, I've got 2x squared there plus an x, and that should be that complete. But that's not what was asked for, it was f of k, so let's go for f of k, and all I'm going to do is replace the x's here. 2k to the power of 3 plus 2k squared plus k, and that should be my final answer there. Right, we're on to part C. So there's quite a lot of work in this this first part anyway. Right, so find the formula for the inverse function g to the minus 1, or the inverse function g of x. Right, so what I'm going to do is I'm going to start with the g of x function first of all. Don't start with that part there, we're going to try and get to that at the end. So to start with my g of x function, which is this one, let's go for g of x is equal to 3x minus 1. So that's my first function, g of x function. What I'm then going to do is I'm going to change the subject to the formula around, and I'm going to say x is equal to. So that's the next thing I'm going to do. So first thing I'm going to do, I'm just going to get the x's over this side here. And this just depends again on the way that you've been taught to do this. I'll then get rid of this minus 1. I'm just going to bring it over to that side, which will give me, if it's negative over there, it will be positive over this side. I'm then going to just divide everything by that 3 that's sitting there. So it's going to be g of x plus 1 all divided by 3. So that formula there and that formula there are the exact same thing. The only difference is that I've just changed the formula around a bit. But now this is the thing we're going to do for the inverse. We're going to change the formula. We're going to change for the inverse function. And what we're going to do there is, wherever I see x, I'm going to change that to the inverse g function. Okay, so the inverse function there. Wherever I see the g of x function, I'm going to change that to x. And there's my inverse function found. So that's my final answer for that one there. Okay, quite a lot of work there, but quite a few questions involved in that one. Right, let's move on to question 2. Right then, for question 2. On the set of real numbers, f and h are defined by these functions that are here. Okay, find f of h of x in its simplest form. Right, so let's start So I'm going to start just by writing this part down here. So for part A, I've got f of h of x, and the first thing I'm going to do is I'm going to substitute the h function into there. That's the first thing I'm going to work on. Right, so from here I've got f of, and the h function is 1 over x squared plus 1. And that should be my first mark in this type of work here. Right, so the next thing I'm going to do is I'm going to then substitute this part here into the f function. And the f function is here, and wherever I see x, this bit in the bracket is going to go down there. So it's going to work out to be a bit of a complex fraction. Right, let's substitute that in first. So there's the 2 on the top, that 2, 3x. So instead of x, what I'm going to be writing is 1 all over x squared plus 1, close the bracket. I've got minus 3 there. And from there, what I'm going to do is I'm going to try and just work out the fractions. Right, so let's multiply out on the bottom line by 3 here. So that's going to give me 3 all over x squared, and that's going to give me plus 3, and there's a minus 3, and these guys are just going to cancel out. So they're going to go. And what that's going to leave me with is 2 all over 3 x squared. Okay? Right, so from there, there's a variety of different ways that I can work that out. I'll show you a kind of simpler way to do it. If I've got 2, I'm going to divide 2 by 3 over x squared. So there's 2, and I'm going to divide that by 3 over x squared. What I'll then do is I'll consider that as 2 over 1, just as a fraction. And what I'm going to do is I'm going to flip and change this part here. So I'm going to flip that fraction over, change the divide sign to times. So there's my 2 sitting there. I've got 3, oh, whoops, didn't flip it, so I'm just going to flip it first. Let me just rub that out. There we go. Right then, so I'm going to flip that, so x squared goes to the top, 3 goes to the bottom, change that to a times, and all I'll do is just multiply straight across the way. So that'll give me 2x squared all over 3, and that there is my final answer. Okay. So there's different ways of sorting it out from here to go to there. Sometimes you can do it in just one jump, but that's maybe some of the mechanics of how it actually works. Right, let's go for part B, okay? And here again, we've got an inverse function, so make sure you look at this part here when you're in your exam. If it's a minus 1, it's an inverse function. Remember, if it's a dash, you're going to differentiate. Right, let's go for it. So find the formula for the f to the minus 1 x and state a suitable domain for the inverse function. Right then, so the way I'm going to do this, I'm not going to start with that, I'm going to start with the f of x function. So f of x is equal to 2 all over 3x minus 3. And what I'm going to do is I'm going to change the subject of the formula. Right, so I need the x's onto the top row. So what I'm going to do is I'm going to consider that as a bracketed term, and I'm going to multiply that up on this side here. So I've got 3x minus 3, and what I'm multiplying it by is that f of x bit, and that equals 2. Right, I'm now going to try and get the x on its own, so I'm going to bring that down to the bottom over there. So I've got 3x minus 3 is equal to 2 all over f of x. And you may have a different way of doing this depending on the way you're taught. I'm going to take that minus 3 over to that side, and that minus 3, when I take it over, is going to be a plus 3. Then I'm going to divide everything by 3 to get x on its own. So that's going to be 2 all over, and I'm dividing there, plus 3 over 3. And I'll just simplify that out. So that's going to be 2 all over 3 f of x, and that's plus 1. So that's what my formula has been changed around to be. So remember, that there and that there are just the same thing. I've just rearranged it. That's all I've done there. So what I'll do is I'll change the f of x function. So I'm going to change to the inverse. Right, so I'm going to change the x, so the x is going to go to f to the minus 1, okay, so that's the inverse. So f to the minus 1 of x, and wherever I see x in this side over here, I'm going to change, so where I see f of x, I'm going to just change it to x. There we go. And there's my final answer for that one there. Right though, so one of the things that we've also been asked to do is a suitable domain for this inverse. So I can't have this part here equaling 0. Okay, so if I can't have that equaling 0, then I would be saying that I can't have x being equal to 0 itself, because 3x equaling 0, x would equal 0. So what we'd say is the domain would be where x will be a subset of all the real numbers, but it cannot be equal to 0. So I'd just say that there. Okay, we're on to question 3. Right then. So question 3, what we've got is a function f of x is 1 over 2x plus 1. To find the largest possible domain available to this function on the set of real numbers. Okay. Right then, so what we'll go for, first of all, we'll start with the equation, the formula or the function. Right, so let's see. I know that this part cannot be 0, okay, so if the denominator cannot be 0, it can't be 0, so let's see what values that we get out of that. So 2x plus 1 cannot be equal to 0, so let's just solve this. So I've got 2x cannot be equal to minus 1, x cannot be equal to minus a half. Okay, and it's going to be on the set of real numbers. So for part A, we're going to say the domain is, we're going to say x is subset of the real numbers, where we cannot have x equal to minus a half. That's that. Part B. Show that the inverse function, so another inverse function question can be written in this form here, okay? So let's go ahead and sort that one out. So remember, we're going to start with the f of x function, 2x plus 1. Change the subject around to have it saying x is equal to. Right, so let's go and do that first of all. Right, so I'm going to multiply up to this side with this part here. So I've got 2x plus 1 times f of x is equal to 1. I'm going to bring that down. I'm going to bring that 1 over, so I'm keeping that together right to the end. So I've got 2x is equal to 1 all over f of x, and that's going to take me to a minus 1 when I bring it over there. And then what I'll do is I'll divide both of these parts by 2. So it's going to be 1 over 2 f of x, and that's going to be minus 1 over 2, minus a half. Okay. So what I could then do is write my inverse function up from here. So I'm going to change, remember, change to inverse. Right, so f to the minus 1, so I'm replacing x with f to the minus 1, and what I'm going to do is wherever I see f of x, I'm going to change that to x. So that's equal to 1 all over 2x minus a half. Okay. Right, so if I look back up at the question to make sure I've got it in the right form, I'm looking up from here and I don't seem to have that there. Okay, so one thing I could do is I could do kiss and smile, or I could multiply this one by x. Let's just do kiss and smile. So kiss and smile, we must multiply that by that first of all. Okay, so that'll give me 2. Then this by this here with a minus sign in between. So that'll give me 2x, and that over there is going to give me 4x when I multiply these together. That's a smile bit there. Okay, so I've got 2, 2 and 4, so if I divide everything by 2, what I'll get is 1 minus x all over 2x, and that there is as required. So that's what I was asked to do there. So I've got it into that form, the inverse function. Right then, so for part C, what we'll do is we're going to say that hence find the two possible values of x such that the inverse function equals the function f of x. Okay, right, so can I just get some room here? What we'll do is we'll start part C up here. Right, so for part C, I'm going to make both of these things equal to each other. So I've got f to the minus 1 x is equal to f of x. Right, what I'll do is I'll take the equation from here, or the formula for here, from here that I've got. So it's going to be 1 minus x all over 2x, and that's going to be equal to the f of x function, which is the one up the top here. 2x plus 1. Right, from there what I'm going to do is I'm going to cross multiply. If I cross multiply, what I'll do is I'll get rid of the fractions. Or what I'm doing is I'm multiplying this side by that and multiplying this side by that. Okay, so I've got 1 minus x and I've got 2x plus 1 is equal to 2x times 1. I'll just write it like that so you can see where everything's coming from. Okay. And then if I multiply the brackets out, so this bracket multiplied out would give me 2x, do the outsides just like I would with FOIL, so it'll give me plus 1. Insides will give me minus 2x squared, and the lasts will give me minus 1 times, or it's minus x, times 1 is minus x, and that equals 2x here. What I'll then do is I'll gather everything over onto the right hand side, okay? The reason why I'm saying right hand side is I want to make that positive, because that's going to help me out a wee bit if I make that positive. Right, so I'm going to have a 0 on this side, so I'll take the 2x over first, the minus 2x over. That'll give me 2x. I've already got that plus 2x there. Bring that 2x over and the 2x's cancel out, okay? Bring that x minus x over, becomes a plus x, and that 1 will come over and become a minus 1. So what I've got there is 2x squared plus x, and that's going to be minus 1, equaling 0. I can then look ahead and see if I can factorise that. So let's try and do that next. And remember, what I'm trying to do is I'm find two possible values, so I'm going to factorise it out. So 2x and x, it'll be a 1 and 1. Looking at that, 1 must be a minus, 1 must be a plus. That one there says it's a plus, so the biggest one that multiplies out will be the plus. So that must be this one here, from there to there. And that's what I've got there. Right, so let's see the values now. So I've got 2x minus 1 equals 0. So from here, 2x equals 1, x equals a half. Okay. And on this side here, of x plus 1, x plus 1 equals 0, so x equals minus 1. So these are my two values. So the two possible values are here. Right,